Welcome. Today, we're going to pull back the curtain on something we do every single day: browse the web. We are going to follow the incredible, lightning-fast journey that happens from the moment you click a link to the second a full web page loads on your screen. I mean, really think about it. You type in a website, you hit enter, and boom, a whole world just appears. But that split second, it's not magic. It's an absolutely incredible chain of events, and we're going to follow that journey step by step. Okay, so let's get started. Your one little click is about to kick off a request that will travel across a global network. And along the way, it's going to meet a whole cast of characters. Things like DNS, the client-server model, HTTP, and the whole front-end versus back-end world. We're going to unpack all of it. First things first, before your browser can even ask for a web page, it needs to know where to send the message. It needs an address. And here's the thing, on the internet, computers don't use names, they use numbers. And that's where the domain name system, or DNS, comes into play. You've probably heard it called the phonebook for the internet, and honestly, that's the perfect analogy. You don't memorize your friends' phone numbers, right? You just look up their name. DNS does the exact same thing, translating that easy-to-remember domain name into the numerical IP address the computers actually understand. So how does that lookup actually work? Well, it's this fascinating, super fast game of telephone. First, your browser checks its own memory, its cache, to see if you've been to that site recently. If not, it asks a DNS resolver, which then kicks off this big search. It starts at the very top with the root servers, which point it to the right top-level domain server, like for .com, which then points it to the final, authoritative server that has the exact IP address. The whole thing is like a relay race that happens in milliseconds. All right, we've got the IP address. Our browser knows exactly where it's going. So now it's time to actually knock on the door and start a conversation. This whole exchange is built on what's called the client-server model. It's a really simple but powerful idea. Your web browser is the client. It's the one doing the asking. And that remote computer at the IP address we just found, that's the server. Its entire job is to listen for requests like yours and send back a response. But, how do they actually talk to each other? Well, they need a common language, a set of rules for the conversation, and that language is HTTP, the Hypertext Transfer Protocol. You'll also see HTTPS, where the S stands for secure, which just means the whole conversation is encrypted for privacy. It's the protocol that makes sure the client and server understand each other perfectly. And this conversation really has two main parts. First, the client, your browser, sends an HTTP request. It basically says, hey, get me all the stuff at this specific web address. The server then gets the request, gathers all the necessary files, like HTML for the page structure, CSS for the style, and JavaScript for any cool interactive bits, and sends back an HTTP response. That response contains the content you wanted and a stats code, hopefully 200 OK, which means everything went smoothly. Okay, so let's zoom in on what's happening on the server's end. When your request arrives, it's not just met by one single thing. It's handled by a whole system that's split into two major parts, the front end and the back end. This car analogy is honestly the best way to understand it. The front end is the shiny exterior of the car, the paint job, the dashboard, the steering wheel. It's everything you, the user, can actually see and interact with. The back end, that's all the complicated machinery under the hood. The engine, the transmission, the computers, all the stuff that actually makes the car go. And if you look a little closer, you can see their goals and even the tools they use are totally different. The front end is all about the user experience, using things like HTML, CSS, and JavaScript to make everything look great and feel responsive. The back end, on the other hand, is all about building a reliable and secure architecture that does all the heavy lifting, using powerful languages like Python or Java. So let's dive even deeper into that back-end engine, because it's usually made up of three key players that all have to work together perfectly to handle your request. First up, you've got the web server. Think of this as the front door, or the gatekeeper. It's the component that physically receives your incoming HTTP request. Its main job is to serve up the basic, static parts of the website, the main HTML page, images, that kind of stuff. But what about all the dynamic information, like your user profile or the items in your shopping cart? That stuff lives in the database server. This is the application's private library, a super specialized system designed to store, manage, and retrieve massive amounts of data with incredible speed and security. So the web server takes the order, and the database server holds all the ingredients. How do they communicate with each other? This is where that classic restaurant analogy comes in handy. You're the client at the table. The chef in the kitchen is the server. And that crucial link between you two? That's the waiter, or in our case, the API. An API, which stands for Application Programming Interface, is that messenger. It's a set of rules that lets different pieces of software talk to each other. The web server doesn't need to know the messy details of how the database works. The API gives it a simple, clean way to ask for some information and get a predictable answer back. It's the glue that holds the backend together. Now, here's the kicker. In the modern web, all these pieces, the web server, the database, the APIs, they almost never live on a single computer sitting in a closet somewhere. Instead, they're all part of a massive, flexible, and distributed system that we call the cloud. Cloud architecture is basically the master blueprint for how all of these front-end and back-end services are organized and delivered over the internet. Instead of buying and managing their own physical hardware, companies can now get on-demand access to virtual computers, storage, and networking from massive providers. And a modern cloud backend is just incredibly sophisticated. It's not one server and one database anymore. It's this collection of specialized services for everything you could possibly need, from the basic server infrastructure and scalable storage to managed databases and super robust security systems. Each piece is like a Lego block in a giant, powerful, interconnected system. So why did everyone move to the cloud? The benefits are just enormous. For one, it's way more cost efficient. You only pay for what you use. But the real game changer is scalability. If your site suddenly gets a huge spike in traffic, the cloud can automatically add more resources instantly so you don't crash. Plus, it offers incredible reliability by spreading data across the globe and centralizing top-tier security.
So there it is. From that single, simple click, your request found an address using DNS. It had a conversation with a server using HTTP. It was handled by this complex backend of web servers and databases, all talking through APIs, all running on a vast global cloud architecture. It's a true symphony of technology, and it all happens in the blink of an eye.
And that leaves us with one final big question to think about. As every service we use moves into this abstract, distributed cloud, our data no longer lives on one machine we can point to. So how does our relationship with that data change when its physical location becomes both everywhere and nowhere all at the same time? Thanks for joining us.